All right, we're going to be I have a video over graphing systems of linear inequalities. All right, now understand that this is a review of concepts that we've already done. We've already graphed lines, we've graphed inequalities, graphing linear inequalities, so we've done that. And so now this is a combination of both concepts, meaning that we're going to include graphing systems of equations by having two equations here, but we're just going to be shading. It's like we have two problems graphed on one coordinate plane. So it's very important that you realize that this is not necessarily a new concept, it's just we're combining concepts onto one paper. All right, so if you need to review graphing linear inequalities, I have attached that video below. So if you want to start with that one and then move into the graphing the systems of linear inequalities, that can help you out a lot. All right, so what we're going to do is we're going to look at finding the area, or not necessarily the area, the space where these two shaded areas overlap. So I'm going to start with kind of this one, 5 here, and my equation is simply just x is greater than or equal to 3. Now in this case, because it's just x is greater than or equal to 3, then it's going to be a solid line at 3. Now the reason why it's a solid line is because it is equal to, meaning solutions do exist on this line, and it's a vertical line straight up and down because the slope is undefined. Okay, we know that because it just has x. If this were a y, it would be a horizontal line, so make sure you pay close attention to that. Now if I plug in 0 here, I mean, I know there's not a y, but I can still use my techniques I used to shade at the other time. So is 0 greater than or equal to 3? That is a false statement. So I'm going to shade very lightly here. I'm actually going to change into a pencil. And then I'm going to shade, so this is this area where this is a solution. Again, because 0, 0 did not work, I'm going to shade in the part that does not include 0, 0. All right, my next job is, I'm going to switch back to the pen, and I need to graph this equation. Now, again, this is slope-intercept form. The y-intercept is -2, and the slope is down 1 over 3, down 1 over 3, and I'm going to kind of generalize this one. Now it's very important, and this is a concept we struggled with in the last portion, is that it's down 1 over 3. Negative slope refers to that my first motion is going to be down or up. Now because this is negative, I'm going to go down, and then over is always to the right. Okay, now I can supplement this line by going up and back here, but do not, this is a common problem, is that we go down 1 and then back 3. Okay, that would generate a positive slope in the form of -1 over -3, which again simplifies to 1/3. Now on this one, again, it's equal to, so what we're going to do is we're going to draw a solid line coming across here. I'm going to try my best to draw a line that's straight. That's about as good as I'm going to get here. And I'm again going to test 0, 0. So I say, all right. Again, I'm going through the same steps I used when I was graphing linear inequalities earlier. It's just, again, I'm graphing it on one coordinate plane. So now I have, is 0 less than or equal to -2? Is 0 less than or equal to -2? Is that a true statement? That is a false statement. Okay, a false statement. 0 is greater than -2, so that makes it a false statement. So that means I'm not going to shade up here above the line. I'm going to shade below. Now again, it's very important that you don't worry about what this line's doing. Kind of just X that out of your mind, and we're going to kind of shade. Let's use blue, and we have the pencil, and so we'll kind of shade here. And so it's going to be down here, and you'll notice that my spot of intersection is this little spot right here. Where our two shaded areas intersect is this little piece right there. And so that's what I'm going to color in as my solution set. And I'm going to make that very apparent that that is where the solution set begins. Box in this line area right here. All right. My next one I'm going to do a little bit quicker. I'm going to show you a different technique instead of just drawing the or coloring lightly. We can also just draw arrows. So let me draw this one real quick. I'll kind of graph these equations real fast. Again, unfortunately for these two examples, I do not. I'll have to work an example down here where I have just a greater than or less than. These ones up here are equal to. Ooh, I can't go with that. So when I do this, I draw that line there. Okay, and then I'm going to draw this one here. So this starts at 2, and my slope is up 5 over 1. So 1, 2, 3, 4, 5 over 1. And now I see 1, 2, 3, 4, 5 over 1, 1, 2, 3, and you're going to kind of see that that's going to end up like that. And I'm going to go with that one right there. Now I'm going to show you guys a technique that I use sometimes, which is the arrow technique. And so what I'm going to do is, let's first start with this one. I'm going to plug in 0, 0. Is 0 greater than or equal to 2? That is a false statement, which means my answers are going to include everything on this side. And what I'm going to do is I'm going to draw some arrows saying I'm going to shade this side. Okay? All right, and my next one, this guy right here, is 0 is greater than or equal to negative 2. That is a true statement, which means that this one is going to include this area right here. All right. Now, this can be, some people like the shading, some people like the arrow technique, but what we try to find is the area where all the arrows are pointing at each other. So in this case, it's not this area because these arrows are pointing opposite direction. It's not this one because these guys are pointing in opposite directions. We look at the area where they're all pointing in the same direction, and in this case, that is this area right here. And so that is our solution set to this particular problem. And I'm going to draw some loops here, okay? So that is our solution to this particular problem, is this area right here, okay? Our next one here is going to be a little bit more extensive. I'm actually going to work number 2 here. These are problems you'll receive in the future. So what we're going to do is we have to solve for y. So this is, again, extending on a technique that you guys learned in the past, which is our solving for y to generate a slope-intercept form. So what we need to do is subtract x, and so we still have that negative sign out in front of y. So we have negative x minus 2. We divide by negative 1, and yes, you are right. We have to flip the sign because it is a negative number we're dividing by. That makes it positive x, and that makes it plus 2. So our solution, or our line, is going to look something like this. And this is very important. I also wanted to cover this, which is that because it's not equal to, it's going to be a dashed line. And this should bring back memories because this is what we did for a long time in the last unit. We graphed linear inequalities. We just had to worry about shading one portion. Now we're kind of looking at 2 problems on one plane. So now what we're going to do is we're going to shade that area. I'm going to use the arrow technique because I think that's kind of a nice way if you're not really shady happy. Alright, so then we got to go, we're going to shade up there. Now I figured that out because 0 is greater than 2. Alright, is 0 greater than 2? No. So that means it does not include the 0, 0, which means it includes up here. Our next problem is, here I'll kind of erase this here. Moving rather quickly here because I want to make sure you guys get enough time to practice these. And so we get 5x minus y is less than or equal to 2. And we get negative y is less than or equal to negative 5x plus 2. So I subtracted the 5x. Divide by negative 1. And again, we're in that situation where we got to flip this sign. Greater than or equal to 5x minus 1. So I'm going to start at negative 1. 1, 2, 3, 4, 5 over 1. And then 1, 2, 3, 4, 5 over 1. And so because it is a solid line, or because it's equal to, that means solution exists on this line, but and not in the case with the other one. Alright, so now we're going to figure out, if I plug in 0, I get 0, 0 is greater than negative 1. Alright, now I look at this and I'm like, man, I can't really tell if that is on 0, 0. I'm really kind of confused. So let me just pick out a different one. Let me pick out 2, 0. So let's plug in 2 for x, and we get 0 for y. And so again, what I'm doing is I'm just picking out another random point to make it easier to identify. So I'm testing this point. Is 0 greater than 9? No, that is a false statement. That is a false statement. Or is that true? If I'm passing out 2, 0, 2, 0, that would make it, is 0 greater than 9? No, that is not true. So we are going to be shading in the part that does not include this point, which is this part right here on this side of the line. Now, with my arrow technique, it's kind of a little bit difficult to see, but your solution set is going to exist. If you see, here's arrows pointing this way, here's arrows pointing this way, and so my solution set is right here. All right? Now, I apologize. It takes a lot of practice with these things, like any kind of general math concept, so make sure you give some practice towards this. Again, I attached a video below that goes over graphing linear inequalities to help you out. So hopefully this video helped. Please email me with any questions. Thank you.